I think Isa wants us to get started, otherwise we're going to be here all night. I'm James Carlyle, this is Roger Willis. We're going to talk about partnerships for R3. So partnerships can be a somewhat dry subject. We're actually going to try and liven it up a bit by thinking about partnerships in code. Okay. So R3 is a consortium of banks that came into existence in 2015, so about a year and a half ago, just over that. And R3 thrives on collaboration. That's its entire raison d'etre. And a lot of the early collaboration we did was between these banks. There are around 80 different financial institutions that are members of R3. And so we started by running projects and looking at use cases together. But more and more, we're looking at partnerships as a way of facilitating implementation. So on this slide, we show some of the things we've done. And this sort of chronological, but back in the midst of time, back in the start of 2016, about a year and a half ago, we started doing stuff with, for example, Ethereum, but at that point we were using Ethereum as an open source product. There was no partnership involved, but we wanted to get collaboration going between these banks. But you'll see a trend as we go through these sort of more recent projects and activities that we've been running, that often we have partners involved. So we have a group of banks that want to work together on something, and we have a partner who might be an integration partner or a software vendor coming in to facilitate, coming in actually to build distributed ledger capability inside their product. And the banks in that case are perhaps already using their products and want to help them move forward and take advantage of the distributed ledger capabilities. Okay, let's go to the next slide. I'm just going to give a very brief intro. So one of these partners is a company called Calypso. It's a pretty sizable company. It builds front, middle, and back office trading applications for banks. And here are some words from Calypso CTO about how they see their partnership with R3. We've got the sound.
As a market leader, we're investing in transformational technology that can fundamentally change our industry. Distributed ledger or blockchain is clearly one of them. That's why this project is such a leap forward. Calypso provides a seamlessly integrated experience with the Corda DLT platform, demonstrating real business value to our customers that they can see from within the Calypso platform.
Corda is the only DLT platform designed from the ground up to address the needs of the financial services industry. We were extremely excited to begin working with Calypso only a few months ago to bring their domain expertise to Corda smart contracts, and we look forward to the next stage of development.
To test the advances of the technology, Calypso, together with the R3 consortium, 5 international banks, and 1 investment management company, have decided to launch a proof of concept and to run it close to real-life.
So I must apologize for the video editing. I'm not a video editor. And apologies for the sound, so it's obviously not hooked up through the sound system. Okay, let's go to the next slide. Oh, of course. Excuse me. There we go. Okay, so as another example of partnerships that we're working on, I want to talk a little bit about Intel. So Intel is a different kind of partner for us. It's more of a, if you like, a strategic partner. The story here is that Intel has this technology called SGX, which is a controlled portion of a chip that they produce, of Intel chips. And this portion of the chip is called an enclave, and it's protected from the rest of the chip, and it's protected from the rest of the computer system and all of the operators of the computer system. And what we wanted to do was take advantage of this in the way that Corda preserves privacy. So Corda treats privacy as a key requirement. That's a differentiator from other distributed ledger platforms. And we knew, because we've been tracking the technology for years, how we wanted to take advantage of it. And what we've done is put, to give a little bit of tech detail, we put a Java 8 compatible JVM, which is the virtual machine that Corda uses, inside an SGX enclave, which is a world first. And we're partnering with Intel to bring that into production. And why are we doing it? So that we can run Corda smart contract verify functions inside this protected enclave, so that people who are working with assets or data that originated somewhere else can know that it's valid because they can trace the transaction chain back to its origin, but they themselves can't see the previous steps in the transaction chain. This is pretty critical when you're dealing with assets on a distributed ledger. You want to move them around between parties. The current holder wants to know how they evolved, what the genesis was, but we don't want the current holder to see all of the previous transactions, because then we get a massive privacy leak. So this gives us this sort of concept of privacy, provenance, and performance all in one. And other approaches, we don't think, give us those three things together. So it's a really important partnership for us. And we're working with other, I guess, large companies to form similar strategic partnerships. Okay. So that's it for the slides. So now we're going to switch, because we wanted to make this a little bit more sort of tech-focused and not talk too much about partners, but talk about Corda. Roger is going to do a live coding demonstration that involves managing partnership agreements. Corda is optimized to manage agreements between parties, so it felt entirely appropriate to talk about partnerships in this way.
Okay, thank you, James. Okay, so what I'm going to do is I'm going to build a Cordapp or a Corda application from scratch. This here is the Cordapp template. It's just a. Could you increase the font size? Yes, absolutely. You can do that. Is that better? Can you all see? Okay. If you can't, then just let me know and I can make it a bit bigger. So what I've done here, I've downloaded the Cordapp template. In fact, I cloned it, and it's the basis which forms my application. So what I'm going to do now is build out this partnership management application from scratch. So what do I need to build this application on Corda? Well, I need three constituent parts. I need a state. And the state represents the shared facts between the various partners of these partnership agreements. I need a contract to govern how these partnership agreements can evolve over time. And I need what's called a flow. And those are the business processes that allow for all of these parties to come into consensus about a particular partnership agreement. So what I'm going to do to begin with, I'm going to start with building the contract.
While Roger's doing that, I should mention that in Corda terms, we have these things called states. They're really records on the ledger. That's all they are. But it's not like key value store records. They can be arbitrarily complex. They're, in fact, JVM or Java objects, Java classes. And so they can contain themselves, they can contain trees of data.
So I'm just stubbing out the verification function for now, but you can see it takes a transaction and it does some computation over it. So this verify function will run inside an Intel SGX enclave. It's a pure function. It has to return the same result, even if it's run at different points in time or by different parties on the network. But for now, I've stubbed out the contract enough for me to continue with building the state. So I'm not sure if any of you guys are familiar with this language. It's called Kotlin. It's a pretty awesome language which targets the JVM. Oh, typo there. And it allows us to kind of quickly build Cordapps compared to Java, which is a lot more cumbersome and slower. A contract state in Corda is really just anything that implements this contract state interface. What I'm going to do now is start defining the properties of our state object. So this is what the parties on the network are going to reach consensus over. because we're using the JVM, we can use any Java library we want, which is pretty useful. So we've got a set of parties for each of these partnership agreements, and we've got a list of projects. But because this is just a toy application, I'm going to just make that a string. So that doesn't need to be too serious. Okay, so what do we got here? We got a couple of properties, a contract, and a list of participants. What I need to do now is I need to link this state up to the contract that governs how it operates or how it can evolve over time. This needs to be a getter, and it will be the partnership agreement. So interestingly, this partnership agreement can be novated. So if you want to upgrade the contract, then you can do that quite easily.
What the platform is doing when it's looking at proposals to change records, transactions, it's actually collecting all of the references to the contract code that governs that evolution of data of the state. And then it's evaluating the verify function, which we mentioned earlier, against the entire transaction, which can contain multiple of these states that are all changing at the same time. And we do this, we have this concept of a transaction so that we can do something called, it's like a database transaction. We can do delivery versus payment. We can move ownership of an asset one way in exchange for ownership of a different asset in the other direction, for example. We can make sure that things that are supposed to happen together do happen together, or they don't happen at all.
So that's contract. This is the state. Whoops. And this is a data class in Kotlin. It gives us equals hash code to string for free, so we don't have to implement all of that ourselves. We don't have to implement getters and setters for all of the properties. These are constants here because we use the val keyword instead of var in Kotlin. I've implemented this function here called doProject, and it adds a new project to the list of projects here. And this plus is just an overloading of the plus operator to add an element to a list, which is quite useful. So what I'm going to do now is start implementing the flows. And if you guys ever use Corda, the flows are probably the most involved part of your application.
What Corda is based on is the idea that in order to have a shared ledger that is simultaneously shared and private, the records of that ledger that apply to people are only held by those people, and updates to those records and transactions to update those records are only shared between participants to the agreements. So to give an example, if I'm transferring ownership of something to someone else, I'm running a transaction with them, but the rest of the network can't see. What the flow does is act as a choreography to allow both sides to verify the transaction's correct independently, and then to sign it independently. And the flow also allows for transaction or elements of the transaction to be shared with specific third parties. So this is another big difference. We get privacy at the transaction level rather than privacy at the channel level, for example. We can share the output of a transaction with a regulator without having the regulator see everything in the channel.
Is one-to-one or one-to-many? What is one with one-to-many transactions? So it's one originator and...
Let's take the questions later if that's
okay, so what I've done here, I've created a simple flow that will create a bilateral agreement on the ledger. Notice that there's not actually that much code here because the majority of the code is actually within other flows that I created. So notice I'm using subflow here, and what that is, it allows us to call other business logic that has been created before. So this create bilateral agreement flow has some logic to create a bilateral agreement, and then to do that, obviously you need a bit of talking back and forth between the two parties involved. So you need one of the parties to digitally sign the proposal, then you need to send it to the other party who then checks it and then digitally signs it if they agree with it, and then they send back their signature. And thus, once all the signatures have been collected, then you can store this bilateral agreement in the ledger, or each node's respective database, which constitutes the ledger. But notice here, there's another collect signatures flow. This is another flow that we created earlier that deals with collecting signatures in a generic way from other parties. And then
this is part of the standard Corda library.
And then there is what we call the finality flow, which deals with getting a signature from the notary cluster, which is one of the consensus services in Corda. So in Corda, there's two strands of consensus. There's transaction verification consensus, which determines whether a proposed update to the ledger is valid as per the contract, which I'll code very soon. And then there's also uniqueness consensus, which concerns whether the update to the ledger is unique. So this here grabs the signature from the notary service. I'm going to go back to my main app, and I just need to do a couple of bits here. So this is so I need to tell Corda that this is a flow that we can start from the node, and that we can start it via the RPC client. But because this is a flow that involves two parties, I need to build out the other side of the flow. So let's call this
what that suspendable annotation is signaling is that both parties are running this code, and they're passing messages between each other directly. And when one of them wants to pass a message over to the other side for verification and signing on the other side, what happens is that the stack is serialized on the sending side, and the message is sent asynchronously. So it's possible to write asynchronous code, but without having a deep nested callback hierarchy or anything like that. So the developer, it looks like they're writing procedural code.
So what I've got here is I'm subclassing this signed bilateral agreement flow, and it makes me override this perform checks method. So imagine you're the other party that wants to assent to this agreement. You want to make sure that it's the right type of agreement. Okay. So in this function here, I'll write a check to do some type checking to see that it's the agreement that I expect to see, for instance. And then we're going to start this flow as a subflow and return its result, which returns a signed transaction. So this is one flow to create, so a set of flows rather to create a partnership agreement on the ledger. But now what I'm going to do is create another bunch of flows that allows the two partners in a partnership agreement to, or actually two or more partners in a partnership agreement to propose a project. Because that's what we do in R3. We do projects in our incubator and accelerator. So what I'm going to do now is write the code to be able to do that.
So while Roger's doing that, perhaps I can answer your question. So the simplest possible arrangement for contracts on Corda is to have two parties in reaching agreement to consensus about facts with each other. But the way that these flows work means that it's entirely possible there are more than two parties involved. For example, there can be n parties. We can have parties who are acting as initiators for transactions, and then other parties that are simply recipients. They simply receive an update to the changes on the ledger. So, for example, a regulator in banking, regulator obviously, we're interested in making regulation more efficient. One way is to have a regulator operate a node on the network and listen for, if you like, read-only copy of transactional updates. And that enables regulation to be faster and more efficient for the regulator, but it also means regulatory reporting is cheaper for banks as well, potentially.
So what I'm doing, I'm pulling the original partnership agreement out of the vault, out of the database which each of the nodes have, and I'm double checking that it. Well, I'm basically pulling them all out and I'm finding the right partnership agreement. And I can do that in a rudimentary way by just comparing the set of partners versus the set of partners that want to create a project. So I'm actually copying all of the partnership agreements into memory here. If you want to create a production app, you totally would not want to do this, but as this is a demo app, it's cool. I think it's sufficient. I return here. This old state value has the current version of the state. But what I want to do, I want to create a new version of the state by adding and add a new project to this new version of the state. So I can do that by getting the old state. So, states in Corda are immutable. So I need to deal with the fact that if I can't find the state, so here I'm using this do project function. I'm going to pass it in the name of the project. So this creates a new state, and then what I do is I pass in the old state and the new state to the update bilateral agreement flow, which is again a prepackaged flow I can use. I don't have to build it myself. In fact, I did build it myself, but you wouldn't have to build it yourself if you had all these flows available to you. And yeah, job done. So now I need to write the other part of the flow, which is actually quite similar to this one, except I need to change a couple of bits. So let's call this Carlyle on project and propose project. I'll do these checks later because I'm feeling a little lazy. I need to add some annotations to this, otherwise Corda will not let you run it. And I also need to annotate this as well. So to make sure our bytecode rewriter rewrites this synchronous code as an asynchronous state machine, otherwise it doesn't do it, and you will get an error. I need to do it here as well. Okay, so that's really the basis of the Cordapp. So I've got my contract, I've got my state, and I've got my two sets of flows. One flow for creating a partnership agreement, and one set of flows for creating a partnership agreement, and one set of flows for proposing a new project. Let's just ignore for the moment what's in these subflows here. Basically, what these subflows do is deal with the back and forth, the digital signatures, and etc. To reach these agreements. But we just abstract all of that away. And indeed, that's what you can do routinely with the flow framework in Corda. You can just abstract all of the complexity away in flows that have been pre-built for you. But what's the most pertinent part of this is building the verify function. So this is the smart contract that determines whether a transaction involving a partnership agreement is valid or not. So what I want to do is pull out the command from the transaction. So a command is something that hints to the intent of a transaction, and it basically tells you what it's doing. So I get a single command. I only ever want a single command in my transactions involving partnership agreements. What I want to do now is switch over the value of the command. So I can switch based on the type. So if it's an issue command, then I can require that some conditions are present in the transaction. If it's an update command, then I can also do the same as well. But then if it's something I don't know, so an illegal argument exception. There we go. Right, so now I need to write the contract code for issuing a new partnership agreement. So The way transactions work in Corda is that they take input states and they produce output states, and the output states are the new proposed state of the ledger. Obviously, if you're creating a state on the ledger for the first time, then there's no input state. So my transaction would reflect that. So in an issuance transaction for a partnership agreement, I would expect there to be no input state in this transaction. So I can do tx.inputs.isEmpty. Like I say, there must be no input states.
One thing that I guess drives us crazy is that developers in R3 are taught that all spelling errors are illegal, and every sentence ends with a full stop, and they can't proceed through code until that's the case.
Yeah, I've got Richard Brown to thanks for that. We also want there to be one output state, and that output state represents the partnership agreement that we're creating on the ledger. And then we get a reference to that state. We want to get a reference to it. So that's tx.outputs. So we get the single state, and we cast it because everything's strongly typed here in Kotlin and Java land. Partnership agreement. Then we can start dealing with the properties of this partnership agreement. So perhaps one property that we want to we want to say, oh, that there has to be more than one partner in a partnership agreement. Okay, so I know these are trivial, but it's just demonstrating how you can actually build these contract constraints. So let's say there must be more than one partner. We also probably want to make sure that there's no projects to begin with, right? So you need to the partnership agreement must precede any projects, of course. So we should say that the projects list must be empty. And then probably lastly, but most importantly, we want to make sure that the right parties sign this partnership agreement. So we want to make sure, so in Corda, we attach public keys to command, and those are the required signers for a transaction, okay? So in a bilateral agreement between Alice and Bob, we would put Alice and Bob's public keys inside the issue command here, okay? So what we need to check is that we do command.signers, and we convert that to a set. So we should have a set of Alice and Bob's public key. We want to make sure that it's the same parties that we have in this partners set here. Okay, so we want to. This is I believe it's a set of public keys. Okay, so I need to do partners. So I get the public keys, and then I convert this to a set. So. Okay, so that's it. We could potentially add a lot more, but I think that's it for now.
One thing that's interesting about Corda also is with this verify function is to verify the correctness of the transaction that's making changes. The generation of the transaction is separate from the verification. The generation can be proprietary, and it can be complex and long-running. The verification typically is very lightweight, and it's very easy to reason. So what we want to do is make it hard to introduce bugs in verification. You can see these rules are very easy to reason with as humans, and we have a very lightweight domain-specific language to specify these in. The other point is that the verification has to be deterministic, so that both sides, when they are verifying, they have to achieve the same. They have to achieve verification consensus. So they're only running lightweight blocks of code, essentially running those very fast, and they're running them inside a deterministic JVM. So the JVM that I mentioned that sits inside the SGX enclave is a deterministic JVM. And that means that certain functions, like the random function, have been blacklisted.
So this is just a trivial constraint here to say you can only add one project at a time. Again, just demonstrating whoops. And I can add another constraint to say project names must start with project. That's pretty important. Certainly in this example here. So are we running out of time?
Yeah.
Okay. I'll be done very soon. Okay, so what I can do, here's some code I made earlier, so I'll just revert this, and I'll add a couple other bits. So this is a progress tracker. It keeps track of the current state of the flow. So what I'll do now is yeah. So I'll kill my all my Java processes. Should have shut them down before, to be honest. And I'll compile this. Hopefully it will compile first time. Might not. So building a Corda project is pretty easy. We just use Gradle. Inside the Gradle file, there's oh wow, that's good. There's a Gradle task that allows you to create nodes. We don't need to deal with Docker or anything like that because the JVM is a virtual machine. We run the nodes on a virtual machine, which is great. And now I want to run the nodes, which is super easy. So I'm running 3 nodes here. So one of them, we've called it the controller, but it's not really a controller. I don't know why it's called the controller. And in there, we've got the network map service, which is the phone book for the network, essentially, as well as it runs a notary service. This is just a singleton notary, but notaries on a production network would be distributed, of course. So nodes load up pretty quick, 13 seconds. So Alice and Bob are both loaded up. So now we can enter into an agreement. So we can list the flows that are available. So I want to start this proposed partnership, and I want to go Bob. There we go. So they've entered into an agreement. So I can check that. So I can see there's now a state on the ledger between Alice and Bob. They've got no projects. They're the participants to this state. We got a transaction hash and an index because this was the only output state. It has an index of 0. If I go to, then I can see exactly the same thing on Bob's node as well. So what Corda guarantees always is that what Alice sees is what Bob sees, and what Bob knows is what Alice knows. I guess we don't have any time to create any projects, so I'll leave it here. But that's just a flavor of how to build a Cordapp or a distributed application on top of Corda. So thanks for your attention.
That's all sweaty.
we also have a technical session with the Tendermint and R3 tomorrow. With much more coding and then the workshop. So it must be an interesting one, isn't it?
And probably if we're out of time, if you have any questions about what you've seen, feel free to grab us afterwards.
It's afterwards. I'm sorry.
Yeah.